Alright guys, we're going to do more on permutations by looking at question number 5 and number 6. So it says in this case, there are 7 horses in a race and a large jackpot for anyone who can pick the finishing order of all 7 horses exactly right. How difficult is that? Find the number of ways possible so the orders that they can finish in. So there are 7 races, which means there are 7 places. You can have a first place, a second place, a third place, fourth, fifth, sixth, and last, which is 7th place. Now, the horses are racing. They're beginning the race. That means each horse has an equal opportunity. Well, theoretically, equal opportunity of winning the first place, of coming in first place. So there are 7 horses that have the possibility of coming in first place. Once the first horse crosses the finish line, first place is no longer available, which means we have 6 viable contenders for second place. After that, a horse comes in second place. We have 5 valuable contenders for third place. What I'm going to do is I'm going to draw circles here that represent the horses. These are my horses. So for first place, these 7 horses have the same opportunity for getting into first place. Suppose this horse right here gets into first place, which means for second place, there's only 6 contenders. Then for third place, there are 5 contenders. Let's say this horse crosses. For the fourth place, there are only 4 contenders. Let's say this horse comes in 4th place. For 5th place, 3 contenders. For 6th place, there are 2 contenders. Let's say this horse comes in 6th place. And for last place, only 1 horse can come in last. 7 times 6 times 5 times 4 times 3 times 2 times 1. Which is the same thing as saying 7 factorial, which is equal to 5,040 ways. So there are 5,040 orders. Possible orders. And that is the solution to my question. Alright guys, let's do question number 6. Number 6 says, how many different ways can a pledge of 20 members, a class of 20 members, choose a president, a vice president, a Greek council representative? No pledge can hold 2 offices. So, we need a president, a vice president, and a Greek council representative. No pledge can hold 2 offices. So president, vice president, council representative. I'll put council for short. Now, there are 20 members in the class. So all 20 members can be eligible for vice president. Let's say we pick 1 vice president. And remember, once we pick that vice president, that person cannot be chosen again. So that means there are 19 options, 19 people left that can be eligible for the slot of vice president. Now, we picked a president. That person can no longer be selected again. We picked a vice president. That person can no longer be selected again. Now, we have to pick a council member, which means there are 18 people left for us to pick from, which means 18 possible people, representatives, can be a part of the Greek council representative. And I can multiply that as 20 times 19 times 18. So let's first make this calculator shorter. Let's clear that. 20 times 19 times 18. That equals to 6,840 different ways. So 6,000 840 different ways that we can have a president, a vice president, and a Greek council representative. Alright guys, that is it to this video. Hope you guys enjoyed it, and I'll see you guys soon. Take care.